Okay, we're picking up where we left off in the previous video, going through section 1.4, which is on quadratic equations. In the previous video, we learned the first two of three methods for solving quadratic equations. In this video, we're going to go through the third method. So, okay, the third method is based on the quadratic formula. And all the quadratic formula is that what they do is they take this completely general form of a quadratic equation, right? So ax squared plus bx plus c, but a can't be 0 or it's just a linear equation, but b and c could be 0. And they solve this with all of the variables, like in complete general, using the completing the square process and get some formula for if you've got any ax squared plus bx plus c where a isn't 0, then you can just plug to find that the x values that satisfy the equation. You can just plug it into the quadratic formula. That's the idea. So we can see how they did this. You know, this exactly how we completed the square is just a little more confusing because you have all these variables. But you start by dividing the entire equation by the leading coefficient here, a. Then you get this. Then they put the c over a, they bring the c over a to the right side, and then they complete the square. They create a perfect square trinomial out of these two terms, just like we did. And so what you can see here is that we would set like the 2, when we did x plus a squared, it was 2 times, you know, whatever the a was equal to b over a. So that's 1/2 times b over a. But then they add that on the end here because you square it. Right, and then what you're left with is x plus b over 2a squared is equal to, and then they also added the 1/2 ba over a squared here, and then they just simplified, took the square root of both sides, applied the plus or minus, and just continue to simplify, and the result is here's x. It's these two values, right, because you have a plus or minus here, and that's the quadratic formula. If you've got ax squared plus bx plus c is equal to 0, so in other words, you have a quadratic equation that you can always, any quadratic equation, no matter how it initially looks, you can put into this form, okay? Then the x values are equal to this formula here. Just plug in the coefficients into this formula. That's the idea. So, okay, let's look at an example. Yeah, like, so you start off with this, something like this. Well, this is a quadratic equation, just we can't see that general form yet. Okay, so subtracting 3 from both sides. Okay, now we haven't changed the equation, but now we can see that general form. So using the quadratic formula, we've got, we have ax squared plus bx plus c is equal to 0. We can see that in this case, a is equal to 1, b is equal to -6, and c is equal to -3. So the quadratic formula is, it's minus b, so we're going to get 6, plus or minus, and then b squared is 36 minus 4 times 1 times -3. All over 2 times 1. Okay, now let's see. 6 plus or minus, so 36 plus 12 is 48. So over 2, so 48 is 24 times 2. That's 6 times 4 times 2. That's 6 times 2 times 2 times 2. So we have 3 times 2 to the 4th. So we can take out 2 2's, which can be 4 root 3. So you've got 6 plus or minus 4 root 3 over 2, which is going to be 3 plus or minus 2 root 3. And there you go. Okay, now it says if a quadratic equation has fractional or decimal coefficients, we have the option of clearing fractions or decimals to create integer coefficients. This makes the application of the quadratic formula easier. Yeah, so if you have decimals or fractions as coefficients, you can turn a decimal into a fraction. You can think about clearing the fractions because the quadratic formula is nice in that, like with completing the square, just using the completing the square process, we had to get a coefficient of 1 in front of the leading term, which could kind of make things a little complicated. But with the quadratic formula, we don't have to have a leading coefficient of 1. So you can see, so this problem is 3/10 x squared minus 2/5 x plus 7/10 is equal to 0. Okay, now we can clear the fractions by multiplying this entire equation by 10. So we've got 3x squared minus 4x plus 7 is equal to 0. And so, yeah, just apply the quadratic formula. So minus b would be positive 4 plus or minus b squared minus 4 times a times c all over 2 times a. So let's see. 7 times 4 is 28. 28 times 3 is, would that be 84? 16 minus 84 is minus 68. So, okay. We've got 4 plus or minus principal square root of minus 68 over 6. 68 is 17 times 4. So, I mean, we can go ahead. Let's take out the I. 17 times 4. Okay. So, we could take out so it's going to be 2i root 17. Okay, so let's see. We end up with 2/3 plus or minus root 17 over 3i. And there's two solutions there. Okay, so with that, there's the three methods that we can use to solve any quadratic equation. The zero product property, which is really the more general method for solving any polynomial equation. Okay, but then the other two are more specific to quadratic equations. You use the square root property in combination with completing the square, or you use the quadratic formula. Now, next, they want to talk about some more specifics of the quadratic formula. You can, if you're using let's take a look. So the solutions to a quadratic equation are given by, so here's the solutions, right? I mean, even for any case, it's not like these are the solutions only if you're using the quadratic formula. We can look at this in general. This is the solutions to any quadratic equation. Now, we can look at b squared minus 4ac. And what they're saying here is that you could start with any quadratic equation. Let's write this one in here, okay? 3x plus 1 is equal to 0. And regardless of how you plan to solve the quadratic equation, if you're going to use completing the square, you're going to factor this, you're going to use whatever, right? You could put it into this form, and one thing you can do is look at what the discriminant is. The discriminant is, if we look at the quadratic formula, the discriminant is what's inside the radical here. So the discriminant is b squared minus 4ac. And that will just give you some information, a quick glimpse into the behind the scenes of the quadratic equation. So this is b squared is 9, and then 4 times a times c is, so okay, that's minus 11. Okay, that's going to give us some information. So what information do we get from this discriminant? Well, okay, what we're looking at is it positive, negative, or 0? That's what we're looking at. Not the magnitude of it, but is it positive? Is the discriminant positive, negative, or 0? And so you can kind of see what the idea is going to be here, in that if the discriminant is 0, well, then you're going to have just one solution. and it's going to be a real solution. If the discriminant is positive, you're going to have two solutions, and they're both going to be real. If the discriminant is negative, you're going to have two solutions, and they're both going to have a complex with imaginary parts. So that's what they talk about here, right? The discriminant is less than 0, two non-real solutions with the I in them, right? Discriminant is equal to 0, one real solution. Discriminant is greater than 0, two real solutions. And so that means we're going to have here, we have two non-real solutions, or it's complex numbers with imaginary parts. Okay, that was this problem here, but what can we just see about this quadratic equation? Well, you start by putting it into that standard form, so it'll be plus 6x minus 3 is equal to 0. So, okay, what's the discriminant? B squared minus 4 times 2 times minus 3. So it's going to be plus 4 times 2 is 8. 8 times 3 is 24. So that's going to be 60. You're going to have two real solutions. Okay, what about 4x squared plus 12x is equal to minus 9? Okay, well, we can do there's the standard form. So b squared, 144, minus 4 times 9. So 16 times 9, 9 times 6 is 54. It's 144, so we've got 144 minus 144 is equal to 0. And so there's going to be one real solution in this case. Okay, now here in this last section, we just look at literal equations, literal quadratic equations, and this is really important to emphasize that you don't have to think about equations in more than one variable. Once you understand all the concepts that we learned in this entire chapter, then you can work with any kind of equation with any number of variables. So like here, let's solve for r. Okay. So we need to solve a quadratic equation in 3 variables, right? Sounds so difficult, but no, it's just, okay, so let's isolate r. So dividing both sides by 1/3 pi h, we get 3v over pi h. Okay, now we just look at this on this side. This is just like a number, right? For a specific volume, for a specific height, this is just a constant. That's how we're looking at it. Some number. Really, more specifically, you could kind of look at that as there's no r over here. Okay, we're solving for r, so there's no r over here. So what we can do is take the square root of both sides, put a plus or minus. Okay, and so we get that, let's see, r is equal to okay, that's fine, but they said r is greater than 0, so we can actually go ahead and take off the minus. Okay, what about, it says solve this mt squared plus nt is equal to z for t. Well, we could just use the quadratic formula here. So mt squared plus nt minus z is equal to 0. We'll just replace all of the variables in the quadratic formula with, instead of a, b, and c, do m, n, and minus z. And that's what they do. And well, we can go ahead and do that. So, okay. T is equal to minus b plus or minus b squared minus 4 times a times c, but there's a minus, so we'll put a plus there, all over 2a. And that's it. There you go.